Today we're going to be talking about simple interest. So I should just start out by letting you know that if you would like to watch the video where I filled in this sheet, it's linked in the description below. So interest is money that you earn for putting your money in a bank, or money that you have to pay if you borrow money from a bank. So there's two different ways to calculate interest. One of them is simple interest and one of them is compound interest, and today we are talking about simple interest. So simple interest is interest that you earn on your original investment only, and we are going to see what that looks like by going through a quick example. So our question here says Carlos invests $1,000 in an account that earns 10% per year simple interest. How much money will he have at the end of 5 years? So I made a table of values where I have year, how much interest they earned, and then the total amount of money in their account. So when Carlos opened his bank account, that was year 0. He had $1,000 that he put in, and he didn't earn any interest. He just put the money in and then walked away. So 1 year later, after that money had been sitting in the account for 1 year, he earned 10% interest. So he got 10% of $1,000. Now to calculate 10% of $1,000, you would take 1,000 times 10%, but you can't multiply by just 10. Percent means per 100, so you multiply by 10 divided by 100, and that worked out to be $100. So that means that Carlos now has his original $1,000 plus $100 in interest for a grand total of $1,100. Now, when year 2 rolls around, his money has now been sitting there for another year. He earns another 10%. He does not get 10% of what is currently in his bank account. He gets 10% of his original investment. So 10% of $1,000 is still $100, so he gets another $100, which means at the end of year 2, he has $1,200. Now in year 3, he gets another 10% of that original $1,000, so he gets another $100. So he now has $1,300. In year 4, he gets another $100, so he gets $1,400 at the end of year 4. And then year 5, he gets another $100 for a grand total of $1,500. So after 5 years, Carlos would have $1,500. 1,000 of that was his original investment, plus $500 extra in interest. So there's a follow-up question. There's actually 3 of them. The first one says, is this linear or exponential? So when something is linear, it means that it is going up or being increased or decreased by the same amount every time. So you're adding on the same number every time, or you are subtracting the same number every time. So here, to get from 1,000 to 1,100, we added $100 worth of interest. And then we added another $100 worth of interest, and then we added another $100 and another $100 and another $100. So we are adding $100 every time, which means that this is linear. If it was exponential, instead of adding the same amount every time, we would be multiplying by the same amount every time. And we'll see that later when we talk about compound interest. So our next question says, write an equation that you could use to calculate the amount of money after n years. So if I think about Carlos and his bank account, he started with $1,000 and then he added $100 every year. So if we go back and we try to think about grade 9, we learned about how to do an equation of a linear function using initial value and rate of change. The initial value is the $1,000. He starts at $1,000. And then my rate of change is what we're going up by every time, which is $100 every year. So the equation should be A for my amount equals $1,000 to start plus $100 times the number of years, because it's $100 in interest every single year. And if you want to check to see if this works, we could try year 5. You could put 5 in for n. 100 times 5 is 500. Plus 1,000 is 1,500. So my equation actually does work. It's $1,000 to start plus $100 times the number of years. And then our last question says, develop a formula for calculating simple interest. Now this part was a little tricky, and I'll try to take you through what I did. What I did was I thought about this equation. So A is my final amount. And then $1,000 is the starting amount. That's the amount of money that Carlos put in his account at the beginning. So in banking and finance, the starting amount is called the principal, kind of like how Mr. Cokewell is our principal, right? But it's not quite the same thing, but it's still spelled the same, and it means your starting amount. Now that $100 was our interest. How did we get our interest? We multiplied 10% of $1,000. So we did 10% of our principal or our starting amount. So what I did was I started with a word equation, and I said that our equation would be our final amount is our starting amount or our principal plus our total amount of interest that we were getting each month times the number of years. So I like to use A for the final amount. Amount starts with A. And then for the starting amount, because it is called the principal, we use the letter P. And then the total interest, like I said, we calculated that $100 by doing $1,000, our principal, times 10% as a decimal. So we did 10% divided by 100. So that is P, my principal, times, and then I stands for the interest rate once it's been divided by 100. And then N is the number of years. And then I just took this equation and I said they both have a P, so they have a common factor of P. I factored that out. P divided by P is 1, and then PIN divided by P just leaves me with IN. So the equation that we can use for simple interest, if we want to do a calculation, is that the final amount A equals the starting amount or principal P times bracket 1 plus I, our interest rate, divided by 100, and then times the number of years. I don't expect you to have to generate that formula yourself. We are mostly going to do questions using this formula in its final form. So you can join me for the next video and we will try an example using that formula.